My teaching style has evolved substantially over the years. Early in my career, I relied on more traditional teaching methods, but began experimenting with algorithmically generated online assessments for Cengage Now. I also began augmenting my courses with online instructional videos, which are uploaded to my highly regarded YouTube channel, the Snarr Institute. As a result of these innovative approaches, I was awarded a grant to develop an online business statistics course. My evaluations for this course hovered at or just above the university average, which is impressive given the material and the algorithmically generated assessments used in the course. Since 2013, I have flipped the classroom. Students learn how to do economic or quantitative analyses before we discuss the material in class. I accomplish this with an instructional YouTube video that is embedded at the top of each problem in online homework assessments. I produce all the videos using desktop software and wrote the problems in the HTML editor of Cengage Now. The videos show me completing these problems using Excel. Because each problem has unique solutions for each student on each take, the videos do a great job of teaching students how to do data or economic analysis or solve problems using Excel. In the remaining video, I'm going to present one particular problem that I'm very proud of. It involves a multiple regression where the data are assimilated assuming a linear form and a normally distributed error. The simulation generates 8 observations of lobster demand using the assumed linear multiple regression model parameters and its assumed normal errors. The HTML code is about 8 pages long. Because there are no matrix operators in Cengage Now, I use scalar functions to multiply matrices, invert matrices, and pick diagonal elements off the covariance matrix. Here is an example of 8 observations. If a student completes this problem and doesn't get the grade that he or she wants, they can retake the problem. But when they retake the problem, these observations are going to be all different, which is really cool. So the student gets lots of practice doing multiple regression analysis. As you can tell from one setup, this problem is pretty comprehensive. It involves students computing the means of quantity of lobster demanded, the price of lobster, and the average customer income. Students then have to fill out the ANOVA table of the regression analysis, the table of coefficients, standard errors, and test statistics. They have to instruct Excel to generate the residuals, copy and paste in values of the regression statistics, answer drop-down menu questions, interpret the coefficient of determination by entering values in these 2 answer boxes, and selecting options from the drop-down menus. Next, they have to conduct 2 coefficient significance tests. The significance level may be 10% on one take, 5% on another, or even 1% on a third. So the significance level varies from take to take as well. The student also has to do the model significance test, interpreting the value of the F statistic and its p-value. Finally, the student has to plug in value of the X variables, the price of lobster and customer income in this case. They have to plug those values into the estimated regression equation. Compute the value of lobsters sold for 2 different scenarios. After the student has copied and pasted values from the multiple regression results computed in Excel and answered the drop-down menu questions, the student can check his or her work by clicking on Check My Work. Typically, I give students 2 Check My Works. And the reason why I do this is because there's a lot of pressure in making sure that every answer blank is answered correctly. In the real world, there's a lot of pressure to do these kinds of analyses correct the first time. After the person has checked their work, they can go back and see what they got wrong. If the student gets 1 or 2 of the answer blanks or drop-down menu questions incorrect, he or she can re-watch the video to figure out how to get the right answers for their incorrect responses. After they have done that and they have no red X's left next to answer boxes or drop-down menus, they can submit their assignment for grading. If they submit their assignment for grading and they miss at least 1 answer box or drop-down menu question, they have to redo the whole problem. So there's a huge incentive for them to do it right the first time. If the student makes an error in a calculation, a copy and paste error, or chooses the wrong item in a drop-down menu, again, they have to retake the assignment. When they retake the assignment, again, as I mentioned earlier, all the numbers in the simulated data have changed. so they have to rework the problem. The regression is estimated by first copying the data into Excel. After pasting the data into Excel, the student clicks on the Data tab, clicks on Data Analysis, chooses the regression option, selects the Y range and the X range for the regression. The Y range is cells A1 to A9. The X range is column B and column C, so B1 to C9. Because the names of the variables were included in the input Y range and input X range, we have to click on labels. We have to also click on residuals because we have to enter the residuals into Cengage Now. Then we click on OK, and then Excel outputs this regression output. I shrink the number of decimal places to 3 or 4, depending on how many Cengage Now wants. Students then copy individual values from Excel back into Cengage Now. For example here, the sum of squares due to regression is 522.197. After I copy and pasted other values into the ANOVA table, I'm going to check my work to show you how it kind of works. I have the sum of squares regression incorrect. The total sum of squares is incorrect. But everything else in the ANOVA table is correct. And the reason why that is because in the ANOVA table, the F statistic, the mean square due to regression, the mean square due to error, the sum of squares due to regression, error, and total, they have to be to 5 decimal places. So I entered sum of squares regression in with 3 decimals and total sum of squares in with only 2 decimals. The Cengage Now problem and the accompanying video do a great job of teaching students how to do data economic analysis before they come to class. When they come to class, they're ready for discussions. The discussions are driven by Excel cases that I've written. In my statistics course, for example, the cases simulate sample data so that every student has different point estimates of the population mean and variance. The questions that are raised by my students during these discussions typically regard the interpretation of results and findings and making the best data-driven decisions. I measure student learning in my courses using the online homework that I just demonstrated and online quizzes. The two are very similar, but with the following exceptions. A, the context of the problems have been changed. B, there are unlimited homework takes, but only one quiz take. And C, conclusions, findings, and decisions are typed up in text boxes at the end of each online quiz problem, but are selected in drop-down menus at the end of each homework problem. Because homework and quiz solutions are unique across students and takes, answer markets do not form, which helps assure that students' work is their own.